Hello everybody, and welcome to another fun geometry lesson. Today we're going to learn about special segments in a circle. We have a property at the top of the page that's important to know. It's about segments intersecting inside a circle. If two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So if you take a look at this picture at the right, it says A times B equals C times D. So we see two chords that intersect in the circle. And A and B are on one chord, and C and D are the links on the other chord. And if you multiply A times B, you get the same thing as if you multiply C times D. So this property is pretty easy to use, and we will get down to it and do some of these examples. The directions tell us to find x. Assume that segments that appear to be tangent are tangent. I don't see any tangents down here though. And we're going to round to the nearest tenth if necessary, which will be necessary on a couple. I do want to mention that problem number 4 is particularly challenging because it involves some of your algebra that you learned last year. So we'll save the best for last. All right, for number 1, we have two chords intersecting in the circle. So we're going to use this property that we just learned, that if we take the distances along the same chord, 2 and x, multiply those together, 2x, will equal 3 times 6. So 3 times 6. And now we just need to solve for x, get that x by itself. So it'll be 2x equals 18. And then we have to divide both sides by 2 to get the x by itself. So x is equal to 9. And that's the answer to number 1. All right, let's scoot. Actually, let's just go down first. Let's go to number 3. So here we have 6 and x on the same chord. So 6 times x will equal 8 times 8 along the other chord. So 6x equals 64. And if we divide by 6 on both sides, x equals 10.7. So there's your round to the nearest 10th answer. And that will be it for number 3. All right, number 5. Number 5 is kind of interesting because we don't have numbers on these other pieces. So what on earth are we supposed to do? This doesn't look like the others that we looked at before, but what I want you to notice is on number 5, all of our chords pass through the center, so they're actually diameters of the circle, and all the diameters of the circle are the same length because the total distance across the circle through the center basically cuts your circle in half. And so each one of these small pieces coming from the center going to the circle itself are radii. They're radiating out from the center. So they're all equal. So this one is actually a little bit simpler of a problem. We know 5 and x plus 2 have to be the same. So x plus 2 equals 5. And then to get the x by itself, all we have to do is subtract 2. And x is equal to 3, and that one is done. All right, number 7. Back to the intersecting chords property. We have 2x and 3x along one chord, so 2x times 3x will equal 6 times 5 along the other chord, 6 times 5. So what is 2x times 3x? Well, 2 times 3 is 6, and x times x is x squared. Remember that from algebra? Now, 6 times 5 is 30. Now we need to get our x by itself. So we're going to divide by 6 on both sides. X squared is equal to 5. And then to get the x by itself, we have to take the square root. The square root will cancel out the square. So x is equal to the square root of 5. We can type that into the calculator and round to the nearest tenth. That'll be 2.2. All right, let's go up here to the top and do number 2 now. Number 2 has one chord that has an x and another x. So we'll do x times x equals, now this other piece is kind of strange because we have this tiny little 2, so we'll go ahead and do that. But after it crosses, we don't really have the distance from the crossing point to the center. We have from the center to the opposite side is 10, but we really need the distance from our intersection point across to the other end of the circle. So I want you to remember, if it passes through the center, we're looking at a diameter, which is comprised of 2 radii. So this side's 10 and that side's also 10. So the distance that we go from the center over to that intersection point would have to be 10 minus 2, which would give us 8. So this part right here is 8. So we're going to do 2 for the little part times 8 plus 10 for the rest of the length, which would be 18. So that one is a little bit more challenging. Involves a little bit of problem-solving skills. Okay, x times x again is equal to x squared, and 2 times 18 is equal to 36. And now to get the x by itself, we undo the square by taking the square root on both sides, and x is equal to 6. Done. All right, I'm going to skip over number 4. I'm saving the best for last. We're going to go down here to number 6 now. All right, number 6. It has more interesting missing information here that we have to figure out. I can see this little 2 part. We know we're going to use that, but how long is the rest of this? From the center to the end, so the radius is 7. So that means from the center all the way out to the opposite end, including that 2, would be 7 as well. So this little piece that we need to know is going to be 7 take away 2. See, this piece is the radius of 7 minus 2. So that's going to be 5, okay? And then that means we're going to need the distance from this intersection point all the way to the opposite side of the circle, which is going to be 5 plus 7, which will give us 12. So in our equation, we'll have 2 times 12 equals, now we have an x up here at the top, but we don't have anything opposite it on the bottom side. But we've already learned in this unit a chord property that if you have a radius that meets a chord at a 90-degree angle, that it passes through the midpoint, which means this would have to be x also. So we've got x times x using prior learning. So 2 times 12 is 24, and x times x is x squared. Now we're going to take the square root on both sides to cancel out the square. And the square root of 24 is going to give us a decimal answer. We will round to the 10th, and that's going to be 4.9. Okay, now number 8. We're going to go 8 times 6 equals 3x times x. I should have told you to pause this video and try that one on your own. Okay, 8 times 6 is 48. 3x times x is 3x squared. And now to get the x by itself, we divide by 3 on both sides to isolate the x squared. 48 divided by 3 is 16. And then to get the x completely by itself, we have to undo the square by taking the square root of both sides. So x is equal to 4. All right, let's go back and do the fun one, number 4. All right, so we've got 3 times 6, no big deal there, and x times x plus 7. How do you multiply x times x plus 7? Do you remember from algebra? You have to distribute. So you've got 18 equals x squared plus 7x. Distribute means you multiply the number outside the parentheses by each of the terms inside of the parentheses. Now, we have two x's in this problem. One is squared and one is not. They're not like terms. We can't combine them. So to solve for x, we have to get this equation set equal to 0 by subtracting 18 on both sides. So 0 equals x squared plus 7x minus 18. And in order to solve this, we have to factor. Do y'all remember factoring from Algebra 1 last year? 0 equals, we're going to set up double sets of parentheses. And we say, well, what times what equals x squared? That's easy. X times x equals x squared. And what are two factors of the number 18 that subtract to give me positive 7? Well, it's not 18 and 1, because 18 minus 1 would be 17. That's much too big. Let's see, 18 is also divisible by 2. 2 times 9 gives me 18. And it just so happens that if I take 9 and I subtract the 2 from it, it gives me 7. So that's the pair of factors I need. So we're going to have a 9 and a 2. And we want our larger term, the 9, to be the positive one so that the 7x comes out to a positive, and then a negative 2 so that positive 9 times negative 2 is negative 18. We basically undid the FOIL multiplication there. So now we're going to set each factor equal to 0. X plus 9 equals 0, and x minus 2 equals 0. So if you subtract the 9 on both sides, x equals negative 9. And if you add the 2 on both sides, x equals 2. Now, this is geometry, not algebra. Sorry, this is super tiny. Let me write this over here. X is equal to 2, or x is equal to negative 9. Would it be reasonable to say that this length on the circle is negative 9 units long, and this one is negative 9 plus 7 units long? It doesn't really make sense, does it? We only have positive distances for measurements of lengths of segments on a circle. So we are going to throw out the negative 9. It's an extraneous solution, and we are only going to choose x equals 2 as the solution to this problem. And if you plugged in 2 here and 2 plus 7 here, you would have 9 times 2, which does equal 18, just like 3 times 6 did. So you can double check it. All right, let's flip over to the back. Now, let's see. We have some important information here, quite a bit of it actually. The top says segments intersecting outside a circle. So the front was 2 chords that intersect inside the circle. Here we've got some segments that are crossing each other outside of the circle. If secants and tangents intersect outside a circle, then two products are equal. A secant segment is a segment of a line, of a secant line, that has exactly one endpoint on the circle. Okay? So that would be like AC. We have a line that passes through the circle twice. One endpoint is on the circle and one is outside. A secant segment that lies in the exterior of the circle is called an external secant segment, and a tangent segment is a segment of a tangent with one endpoint on the circle. So there's a lot of vocabulary here. We've got two important properties, this bullet and then over here. If you look at the pictures here we've got two secants from this one exterior point, endpoints on the circle. Over here on this one, we only have one secant passing through the circle, and the other is a tangent. So let's see. This is AE is a secant segment, and CA is another secant segment. So if two secants are drawn to a circle from an exterior point, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. That sounds like a lot of complicated math words. So, what does that mean? If I take the outside portion and I multiply it by the entire length of the whole secant segment, that will be the same as the other outside portion multiplied by the other whole secant segment. Okay, so basically the outside times the whole secant segment equals the outside of the other one times the other whole secant segment. Ooh, I'm rolling over here onto the other problem. So I guess we'll go over there now before I ruin it. Okay, if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. Okay, so what this one means is pretty much the same thing, except for here the outside part and the whole thing are the same. So you just multiply the outside times itself for that tangent segment. So it's like the outside squared equals the outside part of the other one times the whole secant segment. So outside portion times whole secant. Oops, I was trying to write segment. Secant segment. Okay, so look at the problems at the bottom. There's 6. Can you tell me which 2 have tangent segments? There's only 2 that have tangent segments in them. So see if you can come up with that before I tell you the answer. You can pause the video if you need more time to figure it out. So if you'll remember, a tangent segment is one that does not pass through the circle. It only touches the circle at one point. It doesn't cross through the inside of the circle. It's like it's sitting on the circle. So number 1 and number 4 are the two problems. Put a little triangle around those problem numbers. Those are the two that have a tangent segment. YP is tangent to the circle, it doesn't go inside, and GH is tangent to this circle, it doesn't pass through the inside. All these others have two secant segments, okay? So we're going to start with number 1, then we'll do number 4. These two are more alike. So we're going to take our tangent segment, the 3.3, and we're going to multiply it times itself, which is just like squaring it. And we're going to say that's equal to the outside portion, 2.2, times this whole secant segment length, which would be 2.2 plus x. So 2.2 plus x. So 3.3 is equal to a decimal, obviously. It's 10.89. And then on the right side, we have a number times a sum. So that's going to have to be distributed. So we'll distribute multiplying 2.2 times 2.2, which gives us 4.84, and add that to 2.2 times x, 2.2x. Now we have to get the x by itself. So subtract 4.84 on both sides of the equation, and that gives us 6.05. And all we have over here on the right now is 2.2x. So since those are being multiplied, we'll divide to get the x by itself. And 6.05 divided by 2.2 is equal to 2.75. It says to round the answer to the nearest tenth, so we could round that to 2.8 because the 5 would make the 7 go up 1. All right, let's take a look at number 4. You might want to pause the video and try number 4 on your own, and then check to see if you got it right. Okay, so the tangent segment is GH. So we're going to take that length, 13, and multiply it times itself, so it's squared. And then on the right side, we're going to take the outside portion, which is 9, and multiply it times the length of the entire secant segment, GW. So that's going to be 9 added to 5x. So 13 squared is 169, and then we distribute the 9, which means we multiply 9 times 9, which gives us 81, and then plus 9 times 5x is 45x. And now we have to get our x all by itself. So we'll start by subtracting 81 on both sides. 169 minus 81 is equal to 88. That equals 45x. And now to get the x by itself, we have to divide both sides by 45. And 88 divided by 45 would just round to 2.0. Barely fit, but we made it. Okay, let's go to number 2. So we have 4 problems to practice on now that have 2 secant segments going across the circle. And we again have one hard problem, well, challenging, interesting, fun problem, number 6, where we get to use a little bit more of our algebra. So let's start with number 2. For number 2, we're going to take the outside portion of the top secant segment, 16, and we're going to multiply it by the entire length of the secant segment. 16 plus 26 equals 42. So 16 times 42 equals the outside portion of the lower secant segment, 18, multiplied by the total length of the lower secant segment, which is 18 plus x. All right, now we'll solve our equation. 16 times 42 equals 672. And then we distribute the 18. 18 times 18 is 324. And then we'll add that to 18 times x. And now we have to get x by itself. So I'll subtract 324 on both sides. And that is 348 equals 18x. And then divide by 18 on both sides. So that is not an exact answer. We'll round to the nearest tenth, 19.3. Okay, let's go to number 5 next. So on number 5, we'll take our upper secant segment, the outside portion, 6, and multiply it by the whole length. Now, when you do 6 plus 4x, you can't put those together. They're not like terms, so it'll just be 6 plus 4x. And that's going to equal the outside portion of the bottom one, which is also 6. And we multiply that by the length of the entire bottom secant segment, which will be 6 plus x plus 3. 6 plus x plus 3. Well, we could add the 6 and the 3 because those are like terms. What is that? 9 plus x. Okay, we'll distribute over here on the left. 6 times 6 is 36 plus 6 times 4 is 24, and the x. And now we're going to distribute on the right. Also, it's a double distribution problem. 6 times 9 equals 54 plus 6 times x equals 6x. I know y'all are enjoying putting all of your algebra skills to use here. Okay, so now we have to get our x's together on the same side of the equation. I like to move them to the side with the bigger x. So I'm going to subtract 6x from both sides. So I'll have 36 plus, what is 24x? Take away 6x, 18x. And now I need to subtract 36 on both sides to get my regular numbers together on the opposite side from where the x is. So I have 18x equals 54, take away 36 is 18 also. So now, when I take my 18x equal to 18 and divide both sides by 18, I have x equals 18 divided by 18, which is just 1. Nice. All right. I would suggest that you try problem number 3 on your own. Pause the video, give it a chance, and see how it goes. And then you can check. So we're going to take the upper secant segment, outer portion, 8, and multiply it by the length of the whole secant segment, which would be 8 plus 8 more because the tick marks show congruent segments. So that's 16. And then on the bottom one, we're going to take the outside portion, 6, and multiply it by the whole secant segment, which is 2x plus 6. Okay, now we're going to work it out, solve the equation, use our algebra. 8 times 16 is 128. Distribute the 6, 12x plus 6 times 6 is 36. Now I need to get my regular numbers on the opposite side from where my x is, so I will subtract 36 on both sides. 128 minus 36 equals 92, and that's equal to 12x. And now to get the x by itself, I'm going to divide by 12, so x is equal to 7.7. Did you get it right? I bet you did. Okay, now this one is a little bit more involved on number 6, and we don't have a lot of room. You could always do it on notebook paper instead of on the printout. Okay, so set it up the same. Outside portion of the top one, 8, multiplies by the whole length of the upper secant segment. 8 plus 2 is 10. And then the outside portion of the lower one is x times the entire length of that secant segment, which is 11 plus x. So now we 8 times 10 is 80, and we distribute this x. X times 11 is 11x, plus x times x is x squared. So remember that one on the front where we had the x squared and the linear term x as well? We have another one of those now. So how did we do that? We've got to get it set equal to 0 by subtracting 80 on both sides. So 0 equals, I'm going to put the x squared term first. We usually see these in descending powers of x, so they would be x squared before 11x, and then minus 80 on the end. And now we have to factor this. We need, first, the easy part, what multiplies together to make x squared? X times x. And now we need to come up with factors of 80 that subtract to make 11. Well, there's a lot of factors of 80. 80 and 1 don't subtract to make 11. 40 times 2, 40 minus 2 is not going to subtract to make 11. 3 doesn't go into 80. Let's see, 4 times 20. 20 minus 4 is 16, so that's not going to work. What about 5? What multiplies by 5 to make 80? 5 times 16 equals 80. And what is 16 minus 5? Well, that equals 11. Those are the factors we're after. 16 times 5. We want the middle term to be positive, so we choose the bigger number to be our positive, and then the other ones are negative, so that the product, 16 times negative 5, will give us a negative 80. And now we set both those factors, x plus 16 equal to 0, and x minus 5 equal to 0. And solve. So subtract 16 on both sides, x equals negative 16, add 5 on both sides, x equals 5. Now, what's wrong with one of these answers? Can this length from Q to T be negative 16? No. Works in the algebra world. It does not work in the geometry world. We need these to be positive lengths of segments. So x equals 5 is the answer that we are looking for. All right, that's the lesson for today. Hope you enjoyed it. And good luck on your homework. Have so much fun. Remember to ask for help if you need it, and have a wonderful day.